Today we get to talk about the exact values of a sine, cosine, and tangent, and we're going to derive it. I will also introduce, today or Monday, the unit circle project that you'll be working on. So our goal for today is to apply the definition of sine and cosine to obtain values for the sine, cosine, and tangent of the multiples of pi over 6, which is 30 degrees, or pi over 4, which is 45 degrees. We're also going to use special right triangles, 45, 45, 90, and 30, 60, 90, all today. So this is going to be like the most amazing trigonometric day you've ever had. All right, so let's interpret this. This says you're going to rotate this point, 1, 0, 30 degrees counterclockwise, and you're going to tell me what the values are. You're going to tell me what you get when you rotate it, okay? Now, of course, we know that when you rotate, you end up getting the x value is your cosine of theta, in this case 30 degrees, and your y value is the sine of theta, in this case 30 degrees. So all you have to do is plug those numbers into a calculator to get those values. So do cosine of 30, etc. And you're going to do that for all of those. So if you haven't already, attack, kill, destroy now. So some things to observe. Number one, when we find the rotation of 30 degrees here, notice that the rotation of 60 is just those switched. Nice, nice. Now this is 45 degrees, which is 0.707 and 0.707, so those are the same. And this one over here is 135, which is 90 degrees more. And all we did was take the opposite there, but the height there still stays the same. So also, those are the same. So it has to do with isosceles triangles. It has to do with the 30, 60, 90 triangle here. So we will walk through that together. So if we look at a 45, 45, 90 triangle, the first thing to consider, number one, is that each of these are 45 degrees. The acute angles are 45. That's 90 degrees there. Another thing to point out is it's not part of the name, but it is an isosceles triangle. And we also know that the base angles there are congruent. Base does not mean bottom. Base means the sides of the base angles are the non-legs, the sides that are, the angles that are at the endpoints of the non-legs. That's complex. All right, so we just call this a 45, 45, 90 triangle or an isosceles right triangle. So if you recollect, whatever value this is the same. And on top of that, this one is just multiplied by radical 2.
Oh, that's weird.
Okay? So if you know the leg, you multiply this by radical 2 to find the hypotenuse. Okay? So leg to hypotenuse, you multiply by radical 2. However, what if you know the hypotenuse? What should you do?
Divide.
Ah, wow. We woke up on the right side. So we're going to divide. So, and that's the part that we're going to do. If you know the hypotenuse, you divide by radical 2 in order to get the leg. Okay? And the legs are congruent, so we only have to do it the one time. So let's look down here and note that theta here is 45 degrees. And so here's my point on the unit circle. Notice that the triangle that is formed there, the triangle formed there is exactly that triangle there. So if I call this 45 degrees here, but remember my unit circle means my hypotenuse is 1. If I want to find out what the point is, remember, I have to find the cosine, which is this point here, right? Because it's the length of that. So if I can find the cosine of 45, that's going to tell me this length right here. In other words, the leg of the isosceles triangle. And once we know that leg, we know the sine, which is the height of that leg there, or the height of the triangle. So how do we find that? Well, if I know this one, all I have to do is divide by radical 2. So let me just do that real quick. 1 divided by radical 2 You may or may not remember we're not supposed to have the radical in the denominator. So we do something called rationalize the denominator by multiplying the numerator and denominator by radical 2. In doing so, we've now simplified it to be radical 2 over 2. So I just found the length of this side of the triangle to be radical 2 over 2, which means I just found the cosine and the sine of 45 degrees. Without using my calculator, I just used a 45, 45, 90 triangle. So, a 45 degree angle there. To find the point here on the unit circle, I used the 45, 45, 90 triangle, and I know they're the same because it's an isosceles triangle. Now, let's recollect as well, what about tangent? Remember the definition of tangent is the sine over the cosine of theta. So I'm going to take radical 2 over 2 divided by radical 2 over 2, which is 1. So my tangent is 1. Now we found the cosine of theta, the sine of theta, and the tangent of theta just by using that 45, 45, 90 triangle. Of course, we can just memorize that. Now, notice here, once we found the coordinates of the rotation of 45, of that point, we can extrapolate the other 3 corners of the square. So this corner here, and this corner here, and this corner here. And we're going to use multiples of 45 degrees if you're doing degrees, and it's going to be pi over 4 when we're doing radians, okay? So this one here is the 45 degree, and it's the pi over 4 right there. So this point on the unit circle is pi over 4, which means this one, if we count by 45, we go 45 to 90. So this one's 90 degrees here. And then 135. So if I were to draw that right there, this would be 135 degrees. Keep counting by 45 to get 225 here. And then 270. Now, how do I get the radians? Because converting to radians takes a lot of time, but if we notice a pattern, it's actually fairly quick. So this is just counting by 45s. 45, 90, 135 to 180, 225 to 270, and then add 45 to get here, and then finally you're back. Well, if you just add pi over 4, that's multiples of pi over 4. This one is 2 pi over 4, which we already know is pi over 2. You don't have to write that, but we know that's pi over 2. So this one is 1 pi over 2. This is 2 pi over 2. So this one is 3 pi over 2. Now we have 4 pi over 2. So this one here is 5 pi over 2. 6 pi over 2 is here. So this one has to be 7 pi over 2. And lastly, gives us to 8 pi over 2, which reduces to 2 pi, made us all the way around. Now, we know that this quadrant is positive, positive, and this quadrant is negative, positive. So let's use that information to extrapolate what the sine and the cosine are going to be over here. Well, all we have to do is change the x value. So negative radical 2 over 2, and the y value stays exactly the same. So those are the coordinates of the rotation with 135 degrees. Now, this quadrant down below is negative, negative. Quadrant 3 is negative, negative. So that means both the cosine and the sine are going to be negative radical 2 over 2. And lastly, this one here is positive, negative. So radical 2 over 2, comma, negative radical 2 over 2. how is the tangent going to change? Go ahead and talk real quick. What are we going to write for tangents in each one of those? So let's see, how does tangent change? Well, as said, positive divided by positive will give you positive. But over here, we have a positive divided by negative, and negative divided by negative, negative divided by positive, so my tangents change. But also notice that if we reflect, the tangents are the same here and here, quadrants 3 and quadrant 1 and 3. And then the tangents are the same here, quadrants 2 and 4. So we've now done what I call deriving the square. That is, we found the corners based on the 45, 45, 90. Okay? Now it turns out there is another special right triangle back in the old days of geometry, remember 2 years ago, which was the 30, 60, 90 triangle. For those of you who forgot what a 30, 60, 90 triangle is, it's an equilateral triangle cut in half. Okay?
This is my favorite.
So this one looks like this. If you have a short side x, then your hypotenuse is twice that, 2x. And the long leg is radical 3 times this.
This is my jam.
So what we did was multiply this by radical 3 to get to the long leg. And we multiplied this by 2. We just doubled it to get to the hypotenuse. So let's now derive based on the 30 degrees and the 60 degrees. But here we're focusing on theta right here being 30 degrees. And we know that my hypotenuse is 1. So in order to get to here, all I have to do is divide by 2. So that means the height of this triangle is 1/2. In other words, my sine is 1/2. And now to get to here, I do have to multiply by radical 3, but that's not such a big deal. All I do is place the radical 3 in the numerator. And this here is my cosine of 30 degrees. This here being my sine of 30. So there's the derivation of this puppy. So now I can place my point here, and my coordinates are this. Radical 3 over 2, comma, 1/2. So let's use the definition of tangent now in order to find out what the tangent will be. Remember, it's sine, in this case 1/2, over cosine, which is radical 3 over 2. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So now my 2's drop out. I'm left with 1 over radical 3. And of course, we've got to simplify that, rationalize the denominator. Remember, you don't have to do this unless you forgot. You have to derive it. So here's my result, radical 3 over 3. So that's my tangent right here. The tangent is radical 3 over 3. Again, because this is positive, positive, tangent is going to be positive there. Okay. Now we can find the corners. Here, and here, and here. Straightforward. We know those points just by taking the opposites where appropriate. Again, the cosine's got to change here, so that becomes a negative radical 3 over 2. And my sine, the altitude, stays the same, 1/2. Down here at a negative, negative, both of those have to be changed. So radical 3 over 2 and negative 1/2 is the point there. And lastly, the x stays the same, but the y has changed there. Now deriving tangent. Tangent follows the exact same pattern as before. The tangent of this one has to be negative 3 over 2. Oh, excuse me, 3 over 3. Now this one has to be positive radical 3 over 3. And this one has to be negative radical 3 over 3. Now, of course, the next question is, how do we count? How do we count? here's 30 degrees, which you may or may not know is pi over 6. But that's something you should just memorize. So how do we get to the other ones here? How do I get to this right here, and this right here, and this right here? Well, to count it off, this is going to get us to the next stage. But if we count by 30s, here's 30, here's 60, here's 90, here's 120, here's 150. So this one's 150. Continuing to 180, so this one has to be 210. Continuing, count another 30 is 240 is here, so 270 is there, 300 is here, and 330 is there. Like so. If I count by pi over 6, it sounds like this. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, so this one here is 5 pi over 6. 6 pi over 6 here. 7 pi over 6 is here. And this last one here is 11 over 6
Beautiful.
pi.
This is beautiful, Ira.
Now we're going to look at the last component, which is really nice because the last component is actually exactly this, but just looks like this instead. Instead of having it at 30 degrees, we're going to look at this rectangle, which is 60 degrees. So all we're going to do is flip-flop things around. So it's actually not overly crazy. So notice here, this one here is at 60 degrees, which you may or may not know is pi over 3. That means I need to know this point here, and this point here, and this point here as well. But since this is intimately related to what we just did up there, instead of saying radical 3 over 2, comma 1/2, all we do is switch those. It's 1/2 and radical 3 over 2. So this one is 1/2 radical 3 over 2. On top of that, the tangent is simply the reciprocal of this right here. So the tangent is the reciprocal of radical 3 over 3. So we're going to flip that, which is actually just going to be radical 3. So the tangent here is radical 3. So all we have to do is start changing our signs here. The point over here is negative 1/2 and radical 3 over 2. And the tangent is just the opposite of the tangent I had, radical 3 there. Next, down here, we're going to have negative, negative. So it's negative 1/2 and negative radical 3 over 2. And my tangent is going to be positive radical 3. And lastly here, this one is going to be 1/2 negative radical 3 over 2, and the tangent there is negative radical 3. If you want to know the angles, it's like we're, again, counting by 60s. So this one here is 120. The next 60 is 180, so the next 60 down here is 240. And then the next 60 over there is 300. Now, how do we go to the pies? Here we can count, like we did earlier, we did 1 pi over 6, 2 pi over 6 is this, 3 pi over 6. This is 4 pi over 6, or 2 pi over 3. So 1 pi over 3, 2 pi over 3. Here's 3 pi over 3. 4 pi over 3 is this one here, 4 pi over 3. And 5 pi over 3 takes me all the way to there, 5 pi over 3. And 6 pi over 3 gets me all the way around to the circle, 2 pi right there. So we have now done the entire unit circle in its three separate parts. What we're going to do when we come back next week is we will bring all of that together into a single, what are the things we need to memorize and what's the patterns we need to do. So as you can see, when you do derive it, there is a lot of information. If you choose not to put the angles on the ray that's going there, because that's it's not a necessary component, you could have just put it up there, but of course that just makes this list a little bit longer and this list a little bit longer. So we do have degrees, we do have radians, we have the cosine, the sine, and the tangent, and notice that positive, positive, negative, positive, etc. for each quadrant. Things that you just need to focus on, of course, when you memorize this, is notice the components here that have to be memorized. Obviously, this does, and this does, but those are the same. And what's nice about this and this is that those are the same, just flipped. So there's really only three things you're memorizing, right? This, and this. But then you're memorizing properties that this is an isosceles triangle, so therefore the sine and the cosine have to be the same. And this is just the same triangle, just upright. So these are reversed. You could rederive these, but also good to know those. So besides those 1, 2, 3 things, it's good to note these 3 things as well. So 6 things to know here pretty much. And then after that, we just follow the Q2, Q3, Q4 patterns there, along with counting by multiples of these angles there.